Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on unit normal vector. First, we are going to represent the scalar function and find and consider the unit normal vector, that is n cap equal to gradient phi divided by modulus of gradient phi. First, we are going to find gradient phi, differentiate, find the solution, and represent the given solution. Now, let us see how to represent the solution. First, consider the given, that is given phi, which is equal to x y cube z square. Okay, done. First, to find unit normal vector, we have unit normal vector is defined by unit normal vector is defined by n cap, which is equal to gradient phi divided by modulus of gradient phi or del phi. Now, what is del phi represent? Del phi represent or gradient phi represent dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Now, I am going to differentiate the scalar function phi with respect to x, y and z. That is gradient phi, which is equal to dou by dou x into x y cube z square into I cap plus dou by dou y into x y cube z square j cap plus dou by dou z into x y cube z square k cap. Differentiating each and every function with respect to x, y, z with respect to direction I, j, k. Now, gradient phi, which is equal to, see, I need to differentiate this whole function with respect to x. I have x, yes, y cube z square remains constant. Y cube z square remains constant. Differentiation of x with respect to x is 1 into I cap plus. Now, I need to differentiate this whole term with respect to y. So, what happens? X, we have y cube, y, yes, x, y, z, x and z square remains constant. X and z square remains constant. Differentiation of y cube, we have 3y square into j cap plus I am going to differentiate with respect to the whole term with respect to z. That means xy cube remains constant. Differentiation of z square, we have 2z into k cap, where gradient phi, which is equal to y cube z square into I cap plus 3x z square 3x y z square 3x y square z square into j cap plus 2x y cube z k cap. This is our gradient phi differentiated with respect to x, y, z with respect to direction I, j, k. Done. Now we are going to apply the points for this given what after simplification of gradient phi. That is at the point at the point -1 comma -1 comma 2, where x equal to -1, y equal to -1, z equal to 2. What? Z equal to 2. Now let us simplify. Gradient phi, which is equal to, we have y cube. Y cube means -1 whole cube. Next we have z square. What is z? 2 square into I cap plus 3 remains constant into x. What is x? We have minus 1 into y square. We have y square means minus 1 the whole square. Next we have z square, that is 2 square into j cap plus 2. What is x? Minus 1. What is y cube means? Minus 1 whole cube into z, that is z value is 2 into k cap. Use the calculator so that there will be no mistake in the solution. Okay, that is first minus 1 the whole cube into 2 square into 2 square, you get minus 4. Gradient phi, which is equal to minus 4 I cap, plus or minus, let us see. Now 3 into minus 1 into minus 1 the whole square into 2 square, you get minus 12. So we are going to erase my plus minus 12 j cap, plus or minus, let us see. Again we have 2 into minus 1 into minus 1 the whole cube into 2, to get plus 4 k cap. Then this is our gradient phi. Now after finding gradient phi, we are going to find modulus of gradient phi. How to find modulus of gradient phi? Modulus of gradient phi is defined with respect to square root of this, squaring this term, that is minus 4 whole square plus minus 12 whole square plus 4 square, that is gradient phi, which is equal to square root of 4 square 16 plus 1 12 square is 144, sorry, 12 square is 144 plus 16. Now apply the square root, that is square root of 16 plus 144 plus 16, you get 4 root 11. Modulus of gradient phi, which is equal to 4 root 11. Use the calculator, you will get direct solution. Now using unit normal vector, we have n cap, which is equal to mod gradient phi divided by modulus of gradient phi. What is our gradient phi? We have minus 4 I cap minus 12 j cap plus 4 k cap divided by 4 root 11. In the numerator, we can take 4 as constant. So 4 into minus I cap minus 4 3s are 12 j cap plus k cap whole divided by 4 root 11. 4 get cancelled, n cap, which is equal to minus I minus 3 j cap plus k cap divided by square root of 11. This is the required solution for the given unit normal vector. I hope you have understood each and every step of the given scalar function phi, how to find unit normal vector, how to represent, how to differentiate, and how to represent this solution. For more videos, please do like, share, and subscribe. See you in the next video. Thank you.